Abhayam Joshi.
Present, sir.
Okay. Adarsh Shinde.
Present, sir.
Okay. Ankita. Ankita.
Present, sir.
Right. Chandrasekhar. 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 Harshagowda. Harshagowda.
Present, sir.
Okay.
Present, sir.
Okay. Okay. Janvi. Janvi.
Present, sir.
Right.
Present, sir.
Okay. Mahadev. Mahadev.
Present, sir.
Okay. Mohammed.
Present, sir. Present, sir. Present, sir.
Present, sir.
Present, sir. Present, sir. Present, sir.
Okay. Samir Ahmed.
Present,
Samir
sir.
Ahmed. Okay. Sania. Sania. Sanjay. Sanjay. Sankalp.
Present, sir.
Okay. Sanket.
Yes, sir.
Right. Shiraj.
Present, sir.
Shiraj. Okay. Shivnanda. Shivnanda. Shraddha. Shraddha.
Present, sir.
Okay. Shubham. Shubham. Right.
Present, sir.
Okay. Sumit. 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 Suraya Banu.
Present, sir.
Right. Tejas. Tejas.
Present, sir.
Okay. Vivek. Vivek. Yamunappa. Yamunappa.
Present, sir.
Okay. गांवकर रजत रामचंद्र. गांवकर रजत रामचंद्र. मंजुनाथ. मंजुनाथ. प्रथमेश. प्रथमेश. Joslino. Joslino. Anybody else who joined late? Anybody else here? Yes. Pardon?
Sir, Kirti, sir.
Kirti. Okay, I have marked yours. Anybody else?
Fine.
Yes, I have marked. Anybody else? Anybody else here?
Rajat.
Rajat. Okay. Anybody else? Okay. So if there is any interruption, any disturbance in between, right, in the online class, then let me know. Okay. If there is any voice is not, you are not able to hear the voice, or if you are not able to see the screen, if there is any interruption, let me know, please. Okay. So all of you take your notebooks and pen. Take your notebooks and pen. We will solve examples here on stability factor along with your calcium. Are you able to see the screen, students?
Yes, sir.
Okay, fine. In this example, Design a voltage divider bias circuit. Note down in your notebooks. Design a voltage divider bias circuit for the specified condition. For the specified condition, VCC equal to 12 volts. VCC equal to 12 volts. VCE equal to 6 volt. VCE equal to 6 volt. IC equal to 1 milliampere. IC equal to 1 milliampere, comma, S of ICO equal to 20. That is stability factor with respect to leakage current is 20. S of ICO equal to 20. Beta equal to 100. Beta equal to 100. And VE, emitter voltage. VE equal to 1 volt. 1 volt. Okay, design a voltage divider bias circuit for the specified condition. VCC equal to 12 volt, VC equal to 6 volt, IC equal to 1 milliampere, S of ICO equal to 20, beta equal to 100, and VE equal to 1 volt. So this has been asked in the recent examination, August-September 2020 examination for 10 marks. It's a 10 marks problem. Okay. So let us solve this. So what they have asked, just look into the question. Design a voltage divider bias circuit. They are asking to design the voltage divider bias circuit. We already studied what is a voltage divider bias circuit. So we have to design it for the given conditions. What are the given conditions? VCC is 12 volt, VC is 6 volt, IC equal to 1 milliampere, S of ICO equal to 20, beta equal to 100, and VE equal to 1 volt. Now what is meant by design? Design means you have to find the values of R1, RC, and R. Find the values of R1, R2, RC, and R. This is called as a design. Okay, design means
Sir, can't hear you clearly, sir.
you are not able to hear me clearly. Okay. Shall I increase the voice or like
Echoing,
disturbance
sir.
in between? Huh?
Echoing, sir.
Echoing. Okay. Somebody might have turned on. Just unmute yourselves, all of you. Sorry, mute yourselves, all of you. Mute ಮಾಡ್ಕೊಳ್ರಿ. Please don't unmute. Okay, all of you mute your cell phones. Mute your cell phone so that there is no echoing. Now it is okay. Just see. Now sound
Yes,
is
sir.
okay. Okay, fine, fine. Thank you. See, we have to find the values of the resistances R1, R2, RC, and RE. So this is called as the design part here. Okay. However, in DC analysis, we are open circuiting the capacitors. C1 and C2 are open circuited, so we need not find out their values. We have to find the values of the components, that is R1, R2, RC, and RE. This is called as the design. Okay. Now in this, what all is being given? They have given IC. IC is 1 milliampere, that is collector current. VCE, collector to emitter voltage is 6 volt for the given silicon transistor, right? Then VE equal to 1 volt, emitter voltage, this voltage, emitter to ground voltage, it is 1 volt, right? So these are the given values along with VCC, VCC equal to 12 volts, right? Here what we are assuming is, we are assuming this current as I, this current as I, the current flowing through R1 as I. Okay, so if this is I, then this collector current IC, we are assuming it as IC. Okay, then this current I is split into IB and the current flowing through R2. Correct? The current I, the total current I flowing through R1 is split as IB and also as the current flowing through R2. It is split as IB and current flowing through R2. Okay. Then IC current is there, IB current is there. So I will be equal to sum of IB plus IC. That we know. I is always the sum of the base current and the collector current. I is equal to IB plus IC. And this is the voltage divider bias circuit. That is this circuit, voltage divider bias circuit. Okay. So in this voltage divider bias circuit, now how to go about? How to start solving it? Now what they have asked, just see. So they have asked the values of R1, RC, R2, and RE. These component values they have asked. Now once they have given the value of beta and IC, right? What we can find from IC and beta? What values we can find from IC and beta? We know IC, we know beta. What we can find here? IC is equal to beta into IB, correct? IC equal to beta into IB, or IB is equal to IC by beta. Yes or no? IB equal to IC by beta. So IB equal to IC by beta. IC is given. IC is how much? 1 milliampere. Beta is 100. Okay. So 1 milliampere by 100. IC by beta. That is 1 milliampere by 100. So that will give us 10 microampere. It is microampere. Okay. 10 microampere. Okay. So value of IB is 10 microampere. Right? Because we know IC, we know beta, we can find IB. IC is equal to beta into IB, or IB equal to IC by beta. So that will give us 10 microampere. Now what is IE? So once we know IB, can we find IE? Just now I told IE is the sum of base current and collector current. Emitter current is the sum of base current and the collector current. IE is because IB plus IC current is moving into this emitter terminal. So IE current will be sum of IB and IC. IE is equal to IB plus IC. Fine. So IE is equal to IB plus IC. We know IB and IC they have given. Okay, just now we used it. IC equal to 1 milliampere. They have given. We can find IE. So go on finding out which all are possible. Okay, go on finding out which are possible so that we will be able to find the value of RE. So we know IE. IE is IB plus IC. IB is how much? 10 microampere. Collector current is 1 milliampere. Add them. 10 microampere plus 1 milliampere. How much you are getting? Just check. 10 microampere plus 1 milliampere. Calculate in your notebooks. IE is equal to IB plus IC. 10 microampere plus 1 milliampere. It is how much? Calculate in your notebooks. How much you are getting? 10 microampere plus 1 milliampere. Calculate in your calc. How much you are getting? Anybody? Abhay? How much you are getting?
Calculating.
Calculating? Okay. 10 microampere plus 1 milliampere. 10 into 10 raised to minus 6 plus 1 into 10 raised to minus 3.
1.01 milliampere.
1.01 milliampere. You'll get this, correct? So you'll get 1.01 milliampere. That is IE is equal to IB plus IC. That is 10 into 10 raised to minus 6 plus 1 into 10 raised to minus 3. That will be equal to 1.01 milliampere. Okay. So we got the value of IE, emitter current. Now go to the circuit. RE we want to find. So we know IE. Okay. So can we find out some of the parameter using IE? Just we have to check. Can we find out any of these component values using the value of IE? So what is given here? Just look into the question. VE is given. VE is 1 volt and we know IE. Just now we have calculated IE. So VE is equal to IE into RE. Correct? VE, this emitter to ground voltage, the voltage between emitter terminal and the ground. VE. Voltage between emitter terminal and the ground, that is VE. That is equal to IE into RE. IE, that is the current flowing here, IE into the resistance RE into resistance RE. That gives the voltage VE. VE is equal to IE into RE. Correct? Right? So VE is IE into RE. So when it is VE is equal to IE into RE, we know VE, we know IE. So can we find our RE? Can we find out RE? Yes, we can find out RE, correct? So what is RE? RE is VE by IE, Ohm's law. RE is equal to VE by IE, right? So substitute the values. VE is how much? 1 volt it is given. That divided by IE. IE is 1.01 milliampere. 1.01 milliampere. So how much you'll get? Calculate the value, students. Calculate in your calc here. Don't look into the answer. First calculate. 1 volt divided by 1.01 milliampere.
990.09.
Very good. 990.09 ohms. Exactly. Okay. So you can take it as 990 ohms approximately. Right? 990 ohms. Fine. Okay. So we found out the value of RE. One component value we found out. So what are remaining? R1, R2 and RC are remaining. Okay. So next. So if when this RE is calculated, right? What else they have given? They have given the value of S of ICO. Can we use this S of ICO to find some of the component values? Now, To find out that, we have to know the formula for S of ICO for voltage divider bias circuit. I discussed this in the previous two classes. Okay, so S of ICO of the voltage divider bias circuit. So we know the formula S of ICO for voltage divider bias circuit is 1 plus beta the whole divided by 1 plus beta into RE by RE plus RB. S of ICO is equal to 1 plus beta the whole divided by 1 plus beta into RE divided by RE plus RB. Correct. So S of ICO, this is the equation for the stability factor S of ICO. They have given the value of S of ICO here. S of ICO is 20. S of ICO is 20, right? So here we know the formula for S of ICO of voltage divider by circuit. We have to make use of it. That is S of ICO is equal to 1 plus beta the whole divided by 1 plus beta into RE divided by RE plus RB. Now substitute S of ICO, it is given 20. 20 equal to beta is also given. Okay, beta is 100, current gain. Beta is 100. Substitute. 1 plus 100 divided by 1 plus 100 into RE we have calculated 990 ohms divided by 990 plus RB. 990 divided by 990 plus RB. So now simplify this and tell me how much you will get, students. 20 is equal to 1 plus 100 the whole divided by 1 plus 100 into 990 divided by 990 plus RB. Come on, simplify this. Tell me how much you will get value of RB. We can find out the value of RB from this equation, S of ICO equation. So whenever any problem is asked, use the available equations and go on finding out the unknowns. This is how the approach should be. Use the available equations and the available values and go on finding out the unknown values. We have to see which value if we use, we will get which unknown value. Which equation if we use, we will get an unknown value. We have to check it and accordingly we have to go on using the equations. How much is the value of RB that you are getting here? Others calculated?
Calculating, sir.
Okay, do it. Anybody calculated? Value of RB? Make the simplification and accordingly get the value of RB. Kirti calculated? Kirti? Kirti? Ankita calculated? Ankita?
Calculating, sir. Calculating.
Oh, Okay, okay. Rutik, calculated. Chopde. Sai Prakash. Sai Prakash. Calculating. Okay, okay, do it. Anybody got the answer? Yamnappa.
23,454, sir.
23,454. Very good. Point?
0.44.
Yes, approximately 0.5. RB is equal to 23,454.5 ohms. Exactly. So how everybody are getting that? Anybody not getting? Just check. Tejas, you're getting? Tejas, you're getting the same answer?
Calculating.
Calculating? Okay, do it. Suraya Banu? Suraya Banu?
Calculating, sir.
Calculating? Okay. See here. So 20 is equal to 1 plus 100 divided by 1 plus 100 into 990 divided by 990 plus RB. Okay. That is 20 is equal to 100 plus 1 is 101. The whole divided by 1 plus 100 into 990.
23.454 milliampere.
Yes, yes. 23,454.5 ohms. Ohms resistance, correct? Right? Okay, fine. So 1 plus 100, the whole divided by 1 plus 100 into 990 divided by 990 plus RB. That is 100 plus 1 is 101. The whole divided by 1 plus 100 into 990. 100 into 990 is 99,000. The whole divided by 101. The whole divided by 1 plus 99. Mute your cell phones, please. Anybody wants to tell the answer? 101 divided by 1 plus 99,000. This divided by 990 plus RB. Okay. That will be 101. The whole divided by LCM is 990 plus RB, correct? So 1 into 990 plus RB, so 990 plus RB, so that will come here, 990 plus RB, plus 990 plus RB into 1 is 990 plus RB, so that is plus 99,000. The whole, this divided by 990 plus RB. So this is equal to denominator of the denominator will come to the numerator. It is 101 into 990 plus RB, the whole divided by 990 plus RB plus 99,000, right? Now 20 into this term denominator we have to cross multiply. 20 equal to, we got this, right? 20 equal to 101 into 990 plus RB, the whole divided by 990 plus RB plus 99,000. So cross multiply denominator with this numerator. We get 20 into 990 plus RB plus 99,000 is equal to 101 into 990 plus RB. Then expand it. 20 into 990 is 19,800 plus 20 into RB is 20 RB plus 20 into 99,000 is 1,198 with 4 zeros. This is equal to 101 into 990 is 99,990 plus 101 RB. 101 into RB is 101 RB. So 19,800 plus 198,0000, then minus 99,990. That will give 1,899,810. That is equal to, take 20 RB to the RHS, it will be 101 RB minus 20 RB. That will be 81 RB. Okay, what you have to do is this term plus this term minus this term. Take this term to the LHS, it will become minus. You will get 1,899,810. That is equal to, take 20 RB to the RHS, that will be 101 minus 20. That is 81 RB. Therefore, RB will be equal to 1899810 divided by 81, that comes out to 23454.5 ohms. That is 23,454.5 ohms. Okay, so we got the value of RB, right? We got the value of RE, we got the value of RB. Next, what all are remaining? R1 and R2 are remaining, correct? So in this circuit, R1 and R2 are remaining. We calculated this RB resistance. RB is the parallel combination, note that. Okay, it is the parallel combination. Okay, it is not the R2 or R1, right? It is a parallel combination of R1 and R2 that we have calculated as Thevenin resistance when we were designing the analyzing the voltage divider bias circuit. So it is, we got RB. Now here we have to make the assumption that this current I, it is greater than IB. The current flowing through R1 is greater than the base current. Okay, I is greater than IB because we know that the current flowing into base terminal is in terms of nanoampere. It is very less, right? Whereas the other currents, they are in terms of microampere. So the current I, which is flowing through R1, is greater than the base current IB. This is the assumption. So under this, the same assumption we did when we were analyzing the voltage divider bias circuit also, that the base current is less. Okay, for every analysis, we are assuming the same thing. Base current is less because we know that base current is in terms of nanoampere, whereas emitter and collector current, they are in terms of microampere. Okay, so I is greater than IB here. I is greater than IB. So under this assumption, what will be VB? This voltage VB. This voltage, base voltage. Base voltage is here, where it is at the junction here, junction of R1 and R2. What will be VB? So VB will be equal to VB minus VBE minus IERE equal to 0. We have to apply the KVL to this path here. From this junction, that is VB, then positive to negative, minus VBE, base to emitter voltage, then minus emitter voltage, IERE, that equal to 0. Apply the KVL equation here. Okay, from this junction to the ground, VB minus VBE minus IERE equal to 0. Okay, so if we use this equation, then we get VB is equal to VBE plus V, or VB minus VBE minus V equal to 0. Both are one and the same. VB equal to VBE plus V. We know VB equal to 0.7 volts for silicon transistor, plus emitter voltage is given. They have given it as 1 volt. So it is 1.7 volts, right? 1.7 volts. Now what we know the value of RB. Okay, we don't know the value of R1 and R2. We know the parallel combination of R1 and R2, that is RB we know. We have to find out R1 and R2 from this. Okay. Now what will be the voltage drop across R2? If VB equal to 1.7 volt, what will be the voltage drop across R2? This resistance VB, that is from this junction through base to emitter, through emitter resistance to ground, is how much? That is 1.7 volts. 1.7 volts. What will be the voltage drop across R2 from this junction to ground? How much it will be? Can anybody tell me? What will be the voltage drop from this junction to ground? We know the base voltage VB is 1.7 volts. From this junction to this base to emitter, then through RE to ground is 1.7 volts. Therefore, what will be the voltage from this junction to ground? It is how much? Can anybody think of it? See here, this junction to ground and this junction to ground, are they not in parallel? Yes or no? They are in parallel. This junction through R2 to ground and this junction through VBE through RE to ground, they are in parallel. Correct? So whatever VB voltage we have got, the same voltage drop will be there across R2 also. That is from this junction through R2 to ground. Right? So VB is equal to voltage across R2, that also is equal to 1.7 volts. Because this junction through R2 to ground and this junction through VBE RE to ground, they are in parallel. So this path and this path, they are in parallel. They are in parallel. Okay. So what we get here from that? Voltage drop across R2 is equal to VR2, that is equal to 1.7 volt. So if voltage drop across R2 is 1.7 volt, what will be the voltage drop across R1? What will be the voltage drop across this R1 resistance? Yes. We know VCC. Okay, we know VCC, we know voltage drop across R2. So how much will be the voltage drop across R1? Suraya Banu, can you tell me? Suraya Banu? We know VCC, we know voltage drop across R2. So what will be the voltage drop across R1? It is VCC minus voltage drop across R2. Correct? Correct? VCC is from this point here to ground. Total voltage it is VCC. Okay. So from the total voltage from this point to ground, total voltage after we know that, if we subtract the voltage across R2, what we will get? We'll get the voltage across R1. We'll get the voltage across R1. Okay. So voltage from this point to ground minus the voltage across R2, that will give us voltage across R1. Because VCC is what? VR1 plus VR2. Voltage VCC is VR1 plus VR2. Voltage across R1 plus voltage across R2, that will give equal to VCC. Therefore, voltage across R2 will be equal to, voltage across R1 will be equal to VCC minus voltage across R2. Right? That is what it is written here. So, voltage drop across R1 is 12 volts, that is VCC minus VR2. That will be 12 minus 1.7, that equal to 10.3 volts. 10.3 volts. Now we got R1, we got R2. Drop across R2 we got. Drop across R2 we got. Voltage drop across R1 we got. Now what will be the resistance we have to express in terms of current here? Okay, what is the equation for RB? RB is R1 R2 divided by R1 plus R2. That is parallel combination of R1 and R2. Parallel combination of R1 and R2 is RB. R1 into R2 divided by R1 plus R2. That is the Thevenin resistance or the base resistance RB. Okay. Now again, that is same assumption, I is greater than IB. So R1 will be equal to what? We are expressing this voltage drop in terms of resistance R1 and current. So R1 is equal to the voltage drop across R1 divided by current. Voltage drop across R1 divided by current flowing through this. So we have assumed it as I, current flowing through R1. Okay. So voltage drop across R1 divided by I, that will give the resistance R1. V is equal to I into R, or R is equal to V by I. R is equal to V by I. So voltage drop across R1 divided by current I, that will give the resistance R1. Okay. That is what is written here. R1 is equal to 10.3. That is voltage drop across R1 is 10.3. That divided by I. Now what will be R2 then? R2. What is the voltage drop across R2? 1.7 volts. We know the voltage drop across R2. How much is the current through R2? What is the current through R2 here? Yes, anyone? Current through R2 is how much? See here, current through R1 we know, current through R1. How much is the base current? It is negligible. Base current is very much less. The current I is getting split into base current and current through R2. This current I, which is flowing through R1, it is getting split into the base current and the current through R2. Okay, but the base current is very less, it is negligible. Hence, whatever is the current flowing through R1, that is taken as same as the current flowing through R2. Okay, so I, which is flowing through R1, the same current I also flows through R2 approximately. Okay, so we take the current through R2 as also equal to I. We know the voltage drop across R2, it is 1.7 volt. That divided by I, that will give the value of resistance R2. Okay, R2 is equal to 1.7 volt. That is the voltage drop across R2. Right, voltage drop across R2. That's now we have calculated. Voltage drop across R2, that is 1.7 volt divided by I. Okay, 1.7 volts divided by I. That is R2. Now substitute values of R1 and R2. R1 is 10.3 by I. R2 is 1.7 by. Substitute this. Okay, we know RB. Just now you are told the answer that it is 23454.5 ohms. Okay, that is equal to 10.3 by I into 1.7 by I, R1 into R2 divided by R1 plus R2. 10.3 by I plus 1.7 by I. Simplify this and tell me the answer, students. Just do this calculation. 10.3 divided by I into 1.7 by I, the whole divided by 10.3 by I plus 1.7 by I. Do this and tell me the answer. Just calculate it. See how much you get. Shubham, calculate. Shubham,
Yes, sir, calculating.
okay.
Sir,
Do it and tell me the answer. Okay, okay.
Yes, sir.
Shiraj, got it? Shiraj?
Doing so.
Okay. Anybody got the answer? Do the calculation. Prajwal Gowda. Prajwal Gowda. Harsh Gowda. Calculated. Harsh Gowda. Harsh Gowda Patil. How much you're getting? You're getting this answer?
Yes, sir.
What is the next? 62.21? 21? Next digits? 62.21? Anybody?
Yes, sir.
62.21 next digits after 21?
265.
265 exactly.
265
Into
287.
10 to minus 6. Very good. 62.21 microampere. Okay. So once we calculated I, now we can calculate R1 and R2. We have expressed R1 in terms of I and R2 in terms of I. R1 equal to 10.3 by I. 10.3 divided by 62.21 microampere. That will come out to 165.6 kilo ohms. Just do that calculation. And R2 is equal to 1.7 by I. 1.7 divided by 62.21 microampere. That will come out to 27.3 kilo ohms. So we calculate the R1, R2, then RB we know. Then we have calculated one more RE we have calculated. Okay. What else is remaining? What else is remaining? RC is remaining. This resistance is remaining. Right. So how can we calculate RC? Can anybody just think of it? RC. How to find out? Can we apply the output loop equation to find out RC? We know RE, right? We know RE. Okay. We know RE. Can we find out RC using the output loop equation? Because VCC we know. Okay. VCC no. What is given here? VCC they have given. VCE they have given. VE is also given. Okay. VCC, VCE and VE is given. So VCC is given, VCE is given, VE is given. So can we not find out RC? Yes. Can we find out or not? We can find out the value of RC. Okay. So let us see if it is possible to find out the value of RC by applying the output loop equation. So what is the output loop equation? Applying KVL to the collector circuit, we get VCC. What is the output loop equation, students? VCC, see here, VCC minus ICRC minus VCE minus IER is equal to 0. Output loop equation. Okay, you need not by heart it. You have to know how to apply the equation, how to get it. So we are applying KVL to the output loop. That is VCC minus ICRC minus VCE minus IERE. That is equal to 0. Okay, so that equation we have to use here, output path equation or output loop equation. So VCC minus ICRC minus VCE minus IER is equal to 0, or ICRC we want RC, so rearrange the terms for RC. ICRC is equal to, if you take ICRC to the RHS, remaining terms will be VCC minus VCE minus IERE, or RC is equal to VCC minus VCE minus VE. IERE is VE. Yes or no? IE into RE, emitter current into emitter resistance is emitter voltage, that is VE. That divided by IC. So VCC is known, that is 12 volts. VC is also known, it is 6 volts. VE is also given, it is 1 volt. That divided by IC. Okay, how much is the value of IC? IC value, collector current. Just go back and see here. Okay. IC is given. IC also they are given. Okay, 1 milliampere. IC is also given as 1 milliampere. So just substitute that here. Okay, just substitute that here. So it will be 12 minus 6 minus 1 divided by 1 into 10 raised to minus 3. That will be 5 divided by 1 into 10 raised to minus 3, or that comes out to 5 kilo ohms. That comes out to 5 kilo ohms. Okay, so this is the value of RC. So you have to find out the component values, that is R1, R2, right? Then RC, RE. Okay, so if we know RB, then from RB you have to calculate R1 and R2. You have to express the resistances in terms of current and voltage. Okay, in terms of the known voltage and current, just substitute that. Okay, then find out the values of R1 and R2 from that. Okay, so this is how we are simplifying this problem, right? Okay, so take this example for homework here, students. Try it out at home. In an emitter bias configuration, note down this example. So this example is clear. Previous example, any doubts in this example? Any doubts in this example? In the previous example, any doubts here? Is it clear, this example? This example is clear, students, first example? Yes? Ratan? Ratan? Is it understood, first example? Ratan? Ratan?
Yes, sir. Understood, sir.
Understood, no? Fine, thank you. So take this example quickly. In an emitter bias configuration, ICQ is equal to 1 by 2 IC sat. ICQ is equal to 1 upon 2 IC sat. And IC sat equal to 8 milliampere. IC sat equal to 8 milliampere. VCC equal to 28 volt. VCC equal to 28 volt. And VC equal to 18 volts. VC equal to 18 volt. Beta equal to 110. Beta equal to 110. Determine RC, RE, RB and stability factor S of ICO. Determine RC, RE, RB and stability factor S of ICO. In emitter bias configuration, ICQ equal to 1 upon 2 IC sat and IC sat equal to 8 milliampere. VCC equal to 28 volt and VC equal to 18 volt. Beta equal to 110. Determine RC, RE, RB. That is again the design. Instead of asking it as a design, they have asked it directly as determine RC, RE and RB. Okay, and stability factor S of ICU. So they can ask in this way also, or they can ask design the emitter bias configuration given ICQ, IC set, all this. Or they can ask in terms of determine RC, RE and RB and also the stability factor S of ICU. Either ways. Okay. So this is the emitter bias circuit. Just note down this. You already know this. Emitter bias circuit. Emitter stabilized bias circuit it is. Noted down here. Sanket, is it noted down? Sanket?
Yes, sir.
Fine. Try it out. If you are not getting, I will be there. Okay. I will give the solution. Right. Okay. So is it understood today's example? Is it clear here? Right. Okay. Anybody know any wants to ask anything about today's example? Any questions? Any questions here? Yes. Any questions? Any doubts? Anything not understood? Any problem in understanding? Any clarifications? Anything you want to ask? Harsh Gowda? Harsh Gowda? Chandrasekhar? 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 Rutik? Rutik Chopde? Rutik?
Yes, sir.
Is it understood today's topic? Class, today's
Yes,
example? Clear, right?
Yes.
Any
Yes,
problem
sir.
in understanding?
No, sir.
Okay, fine. Try that example at home, right? Then
Okay, sir.
if you are not getting, then definitely I will give you the solution. Okay.
Sure, sir.
Okay, fine. Okay. We'll wind up the today's class here. Okay, in the next class, I will be continuing with that is collector feedback bias circuit. That is we have to cover up, and then we have to go to the analysis, that is stability factor of collector based bias circuit. I will cover up the DC analysis first, and then I will take up the stability factor of the collector based bias circuit. That will take up in the next class. Okay. Thank you.